Hey guys, Beacon here. In this problem from today's Codeforces round, you're given an array of non-negative integers. You want to know if you can increase the max of an array, the minimum excluded element, by exactly 1. And to do this, you can take exactly one subsegment of the array and change all its elements to some integer k. You have to output yes if you can do it, and output no if you can't. So, first of all, what is the max of an array? Basically, the max is the smallest non-negative integer that isn't in the array. For example, the max of an array 0, 1, 2 will be 3, and the max of the array 1, 5, 7 will be 0. Alright, now time to start with the question. If you perhaps forgot already, we basically want to increase the max of an array by exactly 1. And to do this, we can change an entire subsegment of the array and take all of its elements and change it to an integer k. Now, you might not be sure where to start with this problem, so consider an extreme case. What happens if the max of the array is 0? Well, we can obviously just take the entire array as a subsegment, change it all to 0, and the max of the new array is now 1 because it's just 0, 0, 0, so the minimum excluded is 1. So, if the array we are given has max 0, we can just output yes because we are able to do it. So, we at least got rid of one of the cases. Now, say the max of the array is k. We basically want to make the max of the new array after the operation k plus 1. In an array where the max is k plus 1, can you think of a number that we absolutely cannot have in that new array? Yes. If the max of an array is k plus 1, we cannot obviously have the number k plus 1 because it's the minimum excluded element. If the new array does include k plus 1, then obviously since it's already in the array, it cannot be the minimum excluded number. So, we can iterate through the array and find all the elements that are equal to the max plus 1, so k plus 1. And since we have to remove them by changing an entire subsegment to some integer, we have to at least take the subsegment from the leftmost max plus 1 and the rightmost max plus 1 and change the entire subsegment. After we apply this operation, we won't have any max plus 1 elements in the new array. So what we can do is, we can just iterate through the other elements that we have not changed and see which numbers we need. To get a max of k plus 1, we need every number from 0 to k, so we need every number from 0 to the max of the original array to be there. So we can just put them into a set and remove once we see a number in that set outside the changed subsegment. And now, obviously, if all of the numbers we need are in the non-changed numbers, then we can simply output yes, because we are able to create this new array. And if you're missing 2 or more numbers, then obviously we cannot, because our operation that we did at the beginning only produces 1 more number. So we can't have 2 or more numbers that are missing, we can't put them back in the array, so in that case, output no. So we're left with a case where we're missing only 1 number. Now, if we are, we might be able to complete it by looking back to our first operation and changing the integer that we set all the subsegment to be that integer that we're missing. However, there is a little edge case here. If we don't remove any max plus 1s, then we need at least 1 more element that we need to change to the missing number. So perhaps there might just be less than max number of elements in the array, and then we can't do this. So before we output yes, we need to check whether there are at least max of the original array number of elements in the array before outputting yes. And that is the solution. I hope you enjoyed the solution and stay tuned for more cool and interesting problems. Thank you.